Hello everyone and welcome back. So now we are going to continue our discussion and solve this question which I gave to you in the last video. The question actually asks you to find the number of digits which are given in a particular let's say number. So the examples 1 2 3, it has 3 digits, right? On that note, one very good thing is to whenever you are given these type of question is to think of all the possible use cases and try to write them once as well, right? So now let us solve this question. First of all, let us see how the recurrence relation is going to look like. Okay. So a recurrence relation actually is gonna something like this. Now let us think of this intuitively first, right? So if you can tell me, okay, if I let's say just make my number a little small. So right now I'm dealing with say 1 2 3. 1 second, yeah. So now right now I'm dealing with let's say 1 2 3. If I'm able to tell you that okay, I know the last digit is gonna count to 1, and that is of course gonna be true, and you found for all the other digits which are left. So this number can be so big, you don't need to care about anything, right? This number can be any much big. So let's say even if you're dealing with this many number, right? So let's say 3 1 5 8 4 3 9 5. You can just handle the last digit, right? You know that okay, this digit is gonna be 1, and you can ask your recursion to give you the answer for this. Okay, so that is how we solve the question. That is the mentality which I want all of you to actually think of, how exactly to solve them. So now if you see this, let's say if I have something like this, then what the recursion relation is going to be like. So I can say that number of digits, okay, or let me just call this function directly dig. Okay, so digit in 1 2 3 is gonna be something like 1 plus digit in 1 2, right? So I can just directly write this thing, everyone, because of which if you give me the answer for this is a smaller problem which I have to actually get the answer for, and then I can solve for my bigger problem, right? So we have found a recursion relationship, everyone, recurrence relation. And if I have to make a tree, then that's also going to be a lot easy. So it's going to be 1 2 3. This is going to get called for 1 2. And now this is going to get called for 1. Now I have to of course think for a base condition and everything. So let us now work on that. The base condition I think which will work very nice for this particular question is that if we have a number which is let's say from 1 to 9, I can return 1 as an answer. Depending on platform and the question 0, we can see that if we have to return 1 for 0 or I would say 0, like if we have to take this as a number or not. Because a small I would say caveat in this particular question is that let's say if you have a number 9. Okay, so you're gonna call for, now either you can treat this as a base case, which I'm gonna do, or let's say you basically try to reduce it further and you're gonna get 0. Okay, so we are gonna see how we can reduce it, though we have done previous questions where I've already given you an idea that how we reduce the numbers from starting or to end. Now when you reduce it, okay, you are gonna get 0. So you have to make sure that either this is returning 0 or 1. Based on that logic only you are working or writing your code down. Okay, so let us solve this, everyone. Now let us try to solve this. Now the way we can reduce our number, right? The way we can reduce our number, that is actually something like this, which I think we have already discussed lots of time. So let's say if I have some number 1 2 3, if I divide it by 10, right, I'm gonna get 12.3, and I cannot take it as an integer directly, right? So if I take this as an integer, let me just take all of this as an integer. So if I typecast it as an integer, I'm gonna get my answer as 12. Okay, so let me just write this code and then I think it will be a lot more clear. So if let's say if I'm saying my n is greater than equal to 1 and n is less than equal to 9, okay, then I always know that the answer is 1, so I can directly return the answer. For the use case of 0, I'm taking the answer as 0. Now if it is 1 as well, you can just do it as 1 and your cases will be handled. Just that you have to make sure, and I'm going to show you exactly why you have to make sure. So let us take it 1 and I'm going to show you the problem if we take it as 1, right? If let's say you take this just as your overall, I would say test case, then what the problem is going to be. Okay, and these are some caveat or something which you have to handle whenever you're doing recursion question, because if you even remember in PMI, the overall, I would say work of proving the test case actually falls on us, right? In the sum question as well in PMI, we solved that question and came to the answer. Now let's say, okay, now the next thing is that I will be getting a number. Okay, so I have to get a small answer. Okay, so my small answer, for that I have to first make small number. Now the way I can make this small number is something like this. Integer of n divided by 10. Now why is that the case? Let us quickly understand this as once as well. So let me just comment this whole code. let's say if my A is 99, let's say 123, right? If I print A percentage, A divided by 10, and let me run this thing, you are getting 12.3, right? So what effectively this is helping me do, now this is of course gonna be 12334.5. But if I just typecast this to an integer, then I'm gonna get my number. One second, yeah. Then I'm gonna get my number where the last digit is gonna get removed, right? So we take the percentage to get the last digit, and to remove the last digit, you can just directly call on this number like this. So now I know that, let me just remove this. Now I know that my last digit, right? The last digit which I have, it's gonna basically come to, or basically it's gonna contribute 1 to the answer. For the other thing, I can just call this code, not small answer, small number, yeah. I can call this directly. And once I get, my answer is just gonna be 1 plus small answer. Now I don't want to question this as of now, and I think this is very much clear why I don't want to do that. And you can just return your answer. Okay. So just to prove that, okay, why this is a wrong base case, let me just call it for 9, and you will understand that the answer is gonna be wrong. Okay, so answer is coming out to be true. The reason for that, I hope all of you understand that the reason for that effectively is that we would have called for 9 initially. We would have called I'm taking it as a ditch function for 9. This 9 now would have been actually reduced to 0, where our base case come and kicks in. Now this returns 1, and post this I'm returning 2 after adding this 1 again, right? So I'm adding this 1 again. So for 0 it will be returning from here. I will get my small number as 0, small answer as 1, and the final answer I'm going to make is going to be 2, and I'm going to return 2 here. Okay, so this is a wrong base case. Like, just this is not the base case which we should be thinking in terms of. The right base case is actually if n is greater than equal to 1 and n less than equal to 9, then I'm going to return 1. 0, as I said, you can just see for where you're solving this code. If it is asking you to solve by 0, if you're even asking the interview, just ask an interview that, hey, what do you want me to do for n is equal to 0? Do I have to count it as 1 or not? In a real sense, I think yes, we can leave it as it is because it's gonna be 1. But yes, we have to make sure that we avoid this kind of we always include this base case as well. Okay. So because for all the base case, we have to handle this thing. Recursion is not gonna handle that for us. Recursion will do this work. Small answer work, you don't have to do anything. You can just assume that everything is gonna be fine. And yeah, I think this works as better as any code, and you will be getting your answer right. So let me run this for all of you. I think it's not saved. Yeah, 1, 3, and 6. Okay, so let us quickly just see this in Python tutor as well, everyone. So I think it's pretty straightforward, but then again, I want to make sure that you understand the full understanding. So see, when this function first gets defined, and then we are going to call for 9. 9 is a very easy and simple base case, so we are just going to return from 3, and we are going to get our answer, that is 1. When we go for 1 to 3, okay, first it's going to check for both the base condition, and that's of course not the answer. Small number, now pay attention to small number. It's going to be 12 because I've typecasted it into integer. Now for my small answer, I'm going to make another call. Here now 12 is going in n. Again, that's not going to fall into any of the base cases. So I'm going to call out recursion. Now let us see, small number is going to be 1. This time it's going to get called. We are going to get the answer as 1. These functions are still waiting in the stack. They will get removed once they have finished their execution. I got the answer as 1. So my this 12 one, this can now return 2 as an answer. And now the next one, it can actually return 3 as an answer. Okay, so this I hope helps. Now of course for 0, if answer is 1, then also you're going to get the answer as 1 only for 0, right? So great everyone, I hope this is clear. Now in the next class we are going to do another question, and now I would say notch things up a little. So we are going to do where multiple cases can be there. We are going to learn, or I would say do a very important and famous question again, the Fibonacci number. So let us start that in the next class, and yeah, thanks, and let's meet in the next class. Thank you everyone.